Welcome to SSR Pharma Media, your trusted source for pharma knowledge. Pharmaceutical Inorganic Chemistry MCQ series, your exam power boost. Today we are going to discuss about acid-base chemistry and buffer system. Prepare, practice, succeed. So in acid-base chemistry and buffer system, we are going to cover acid-base chemistry and buffer system in pharmacy, definitions of acids and base, buffers, pH scale and its significance, buffer equations, and calculation of pH for buffer solution. And it is the part 1 today we are going to cover. And part 2 is the isotonicity, application in IV fluids and ophthalmic solutions. We are going to cover under part 2. So first is what is acids and base. So definition of acids and base. So already we have discussed about acids and base. According to, there are 3 scientists, they have given their own definitions for acids and base. So according to the Arrhenius theory, so acid means which produce or donates hydrogen ion in aqueous solution. So the same scientist told that it donates or produces OH minus ion, hydroxide ion in aqueous solution and forms water. So according to Arrhenius, he gave the definitions for acids: donation of H plus ion in aqueous solution and donation of OH minus ions in aqueous solution. And the key concept of this Arrhenius theory is acid-base reaction depends on ion formation in water only. So this, according to this theory, it's a disadvantage of this is it is only limited to aqueous system. So when the substance are when dissolved in aqueous system, in that case he explained acids and base based on the donation of hydrogen ion and OH minus ion. But he couldn't explain the when other solvent other than the aqueous like a chloroform, alcohol, like other organic solvent, he couldn't explain. It's a disadvantage of this Arrhenius concept. For example, acid means donate the hydrogen ion, hydroxide means donate OH minus ion in aqueous solution. So, Bronsted-Lowry theory, according to his theory, proton, he explained based on the proton donors. So, acid means it donate the protons and base means it accept the protons. So, protons also hydrogen ions only, but it's the acceptance and donations in the other than water. He explained other than water. In water also only he explained about the proton donor and proton acceptor. So accepting the protons, proton donation of proton is called acid, and acceptance of protons are OH minus ion. Acceptance of hydrogen ions is called base. So only here H plus ion is involving donor and acceptor of protons. And this key concept is it's mainly involving the neutralization proton transfer. And it is mainly applicable includes conjugate acid base formation. For example, hydrogen ion means it's donate the HCl's donate the hydrogen ion, and ammonia is a base, it's accept the hydrogen ions. And Lewis theory, according to Lewis theory, the electron pair is involving. The electron pair acceptor is called acid. Electron pair donor is called base, according to Lewis theory. And the key concept is forms coordinate covalent bond. So it's mainly applicable most general theory and covers non-protonic acid. So that means mainly it's involving wherever the proton is not present. Protons and electrons are protons are not present in that case. So based on the electron donor and acceptor, he explained acids and he differentiated the acids and base. For example, B3, BF3. In this, it is a type of acid, and ammonia is a base. So in this BF3 is the acids donate the electron pair, and so donate the electron pair, sorry, acid base ammonias donate the electron pair, and this BF3 is the acids accept the electron pair and thereby form the complex. So it is called Lewis theory. So base means is to donate the electron pair, and acid means is accept the electron pair. Due to that, the complex formation takes place. So according to Lewis theory. Move into the questions. According to Arrhenius theory, which of the following correctly defines an acid? So option C, proton produces protons, H plus ions in aqueous solution. Which of the following is a limitation of Arrhenius acid-base theory? So option C, applicable only to aqueous solutions. Which concept is central to Bronsted-Lowry acid-base theory? So option C, proton transfer. According to, in this reaction, HCl and ammonia to form H plus ion and Cl minus ion. According to Bronsted-Lowry theory, H3 act as H3 act as accept a proton. So H3 is act as accept the proton. Sorry, it's H3 is accept the protons from HCl. So it's act as a base. So H3 is accept the proton from HCl and it form NH4 plus. So it's accept the protons. BF3 reacts with NH3 to form complex BF3 NH3 complex. According to Lewis theory, BF3 is act as a, so option D, electron pair accepted. So due to the accepting of the electron pair from ammonia, it form complex. Which acid-base theory is most general and can explain reaction without proton transfer? So option C, Lewis theory. So next we will discuss about the buffer. So what is buffer? Buffer is produced to prevent the or to resist the changes in pH. So a buffer solution is one that resists change in pH when small amount of acids or base added. So according to that, the types of buffers are acidic buffer and basic buffer. So acidic buffer compositions are weak acids and its salts. Example, acetic acid and sodium acetate. So pH is below 7. So basic buffer means it's a weak base and its salt. Example, ammonia and ammonium chloride. It's above 7. So mechanism of action neutralizes added acids or base and maintain constant hydrogen ion concentration. Pharmacologically, buffer is very important. Maintain drug stability and improves bioavailability, prevent tissue irritations and maintain physiological pH. A buffer solution is best defined as a solution that, option C, resist change in pH when small amounts of acids or base are added. Which of the following correctly represent an acidic buffer system? Option C, acetic acids and sodium acetate. The pH range of a basic buffer is, so option D, greater than 7. Which of the following is a pharmaceutical important of buffers? So option C, maintain drug stability and physiological pH. Acid-base chemistry and buffer system, in that we are going to see about the pH. What is pH and pH calculations? So pH is a negative logarithm of hydrogen ion concentration. So it's a formula, pH is equal to minus log H plus ion. 1 pH unit change is equal to 10 into change in hydrogen ions. So these are all the pH value according to that the compounds, nature of the compounds. And significance of pH is very important biologically. Its blood pH is 7.35 to 7.45, and blood buffer system carbonic acid bicarbonate, and enzymes activity is pH dependent, and pH imbalances leads acidosis or alkalosis. Is a very important in biological point of view. And in pharmaceutical importance are, it's affect drug stability. When pH is any differences are there, that affect drug solubility and influences drug absorption, controls chemical stability, determines ionization of drugs. And formulation, in the formulation point of view, it's very important. In the ophthalmic solution, pH 7.4, and parenterals nearly physiological pH, and buffers used to maintain required pH. Which of the following statement about pH is correct? So option C, the pH is negative logarithm of hydrogen ion concentration. According to the pH scale, a solution with pH 9 is classified as option D, weakly alkaline. Which of the following biological function is not influenced by pH? Option C, DNA transcription. The pharmaceutical significance of pH includes all of the following except option D, maintaining osmotic pressure. Which formulation requires maintaining a pH close to 7.4 for safety and efficacy? So option C, both A and B, both ophthalmic solutions and parenteral injections. A patient with blood pH 7.2 is likely experiencing option A, acidosis. The pH of 0.001 m HCl solution is, so the answer is option D, 4. So in this calculation, we have to calculate the pH of HCl, 0.001 m HCl. In that, hydrogen ion concentration they have given 0.001. So this is the hydrogen ion concentration. So when we are taken to the power 10 to the power of minus 3, 1, 2, 3. So 10 to the power of minus 3. And so when we are substituting this formula, pH is equal to negative logarithm of hydrogen ion. We are substituting instead of hydrogen ion 10 to the power of minus 3. So here 3 log 10 base 10 is equal to 3. So here 3. Negative will cancel. So minus 10 to the power of minus 3 and minus negative logarithm will minus cancel. So it gives 10. So hence the correct answer is 3. So not a 4. So pH is 3. In this solution, pH is 3. So next, calculate the pH of solution having H plus ion 3.2 into 10 to the power of minus. So in this questions, they already given the log value for 3.2 is equal to 0.505. So when we will calculate the pH of this solution is, so answer is option C, 4.49. So when we are pH is equal to negative logarithm of H plus ion. So H plus ion concentration they have given 3.2. So 3.2 into 10 to the power of minus 5. So when we are substituting, we'll take the log for the both the value 3.2 and 3.5. So in that case, minus log 3.2 plus log. So in the log, A into B is equal to A plus B, we can write it. So in the such way, minus log 3.2 plus log 10 to the power of minus 5. So already log 3.2 log value here they have given 0.055. So in this log 10 to the power of minus, so log minus values are 10 to the power of minus is there. So minus log minus 5 log 10 base 10, log 10 base 10. So for the log 10 base 10 value is equal to 1. So minus 5 into 1 is equal to minus 5. So 0 point minus 0 point uh, 0 0 5 minus 5. So when we are, so here minus is there, when we are multiplying with the minus, so minus into minus plus, so 5 minus into minus 5, so plus 5 minus 0 0.505, so it gives 4.49. What is the pH of a solution having OH minus ion is equal to 1 into 10 to the power of minus at 25 degrees Celsius? So here answer is option B, 10. So pH is equal to negative logarithm of hydrogen ion. So same like that, POH also is equal to negative logarithm of OH minus ion. So here already they have given OH minus ion. We will substitute in this formula 1 into 10 to the power of minus 4. So 1 into 10 to the power of minus gives 10 to the power of minus 4. So when we are taking log of this value, log 4 minus into minus plus. So log 4 log 10. So it's a base 10 is equal to, for this is equal to 1. So 4 into 1 is equal to 4. So at 25 degrees Celsius, so now we have find out the POH value is 4. POH value is 4. So but we have that we want to determine the pH. So pH is plus POH is equal to 14. So in the solution, H plus ion OH minus equal, it gives 14. So we'll substitute in this POH already we have determined it. So instead of POH, we'll substitute the 4. So 4 we are substituting means pH is equal to, so 4 will bring to this side. So 14 minus 4. 14 minus 4 gives 10. So the answer is 10. Option B. So same sum only. The pH of 0.01 m NaOH solution is. So NaOH solutions containing only OH minus ion. So there is no H plus ion. So we have to find out the POH. Then the POH we have to substitute in the pH plus POH formula is equal to 14 and we will get pH value. If you see, so answer is option C, 12. So POH value is 0.1 into 10 to the, converting, it gives 10 to the power of minus 2, and POH formula, so we'll get log 10, 2 into 2 plus 2, 2 minus into minus plus and in 2, and log 10 and base 10 values 1, so it gives 2. And we are substituting the pH plus this formula, pH is equal to, instead of POH we are substituting 2. So already 14 in the plus value, when you bring into this side it becomes minus. So it gives 12. So the answer is 12. So next, acid base chemistry and buffer system. We are going to discuss about the acidic buffers. So buffer mechanisms and buffer. Acid plus salts acidic buffer, and basic alkaline buffer is called base plus and its salt is called basic buffer. So first of all, what is acidic buffer? A buffer solution with pH less than 7 prepared by mixing a weak acids and its salt with a strong base. So general composition, weak acids and its salt, weak acids, strong base. Example, acetic acid plus sodium acetate, citric acid plus sodium citrate. Mechanisms: added H plus ion combines with the acetate ion, added OH minus ion is neutralized by weak acids, and pH range 3 to 6. Same time, alkaline buffer means it's a buffer solution with pH above 7 prepared by mixing of weak base and its salt with strong acids. So general composition, weak base salts of weak base plus strong acids. Examples ammonia and ammonium chloride and tris buffer. And mechanism, when added H plus ion neutralized by weak base and added OH minus ion combines with the ammonium ions. So pH range is 8 to 10. So these are all the examples of pharmaceutical buffers and its a pH range and applications. Application of the areas. So next is the buffer equations. Buffer equations called as Henderson-Hasselbalch equation. So this is called the buffer equation, Henderson-Hasselbalch equation. pH is equal to pKa plus log salt divided by acids. So here pKa is equal to negative logarithm of Ka of weak acids and salt is the concentration of conjugate base. So acid is the concentration of weak acids. So this is the same time basic buffer. It's acidic buffer. It's a basic buffer. POH is equal to pKb plus log salt divided by base. So here salt divided by acid and pKa. Here pKb salt divided by base. And pH is equal to 14 minus POH. So it gives pH value. So there is the difference between acidic buffer and basic buffer equation. So commonly both equations are called as Henderson-Hasselbalch equation. It is called buffer equation. So in buffer equations and pH calculation is, so pH, calculate the pH of buffer containing 0.1 m acetic acid and 0.1 m sodium acetate. So both the pH is 7.46 into log 0.1 divided by 0.1. So 0.1 divided by 0.1 will get cancel. So log 1 value is log 1. So log 1 and base 10 is value is 1. So the pH is 4.76. That means at 50% of neutralization point, the salt divided by acid is equal. So that's called 0.1 divided by 0.1. So both will get cancelled and then only pH is equal to pKa. So pH is equal to pKa. So next calculate pH of buffer containing ammonium and ammonium chloride. So same like that, salt at 50% of neutralization point, salt and bases are equal concentration. So here the value of ammonia is 7.47. So POH is equal to 4.75. So this POH you have to substitute in this formula. Already I told pH plus POH is equal to 14. So POH we already pH is equal to 14. POH in this side plus when we bring into this side become minus 4.75. So it gives 9.25. Which equation is used to calculate the pH of an acidic buffer? So option C, pH is equal to pKa plus log salt divided by acid. Which equation is used for calculating pH of basic buffer? So the answer is option B, POH is equal to pKb plus log salt divided by base. So an acidic buffer is prepared by mixing of 0.2 m acetic acid and 0.1 m sodium acetate. The pK of acetic acid is 4.76. Calculate the pH of the buffer solution. So option is option A, 4.36. So you substitute all the values in this formula. So they have given the A minus, that means acid. This is called is a salts and divided by acids. So salt values 0.1 m. So sodium acetate is a salt. And acid, HA is acid. So acid value, acetic acid value is 0.2. And pKa value they have given, so 4.76. So if you are substituting this value in this formula, pH is equal to pKa plus log 0.1 divided by 0.2 is equal to, so when we are cancelling this one, we'll get log 0.5. So now log 0.5 is equal to, for log 0.5, this 7.46. So 7.46. So now pH 7.46 and pH is equal to 7.46 minus 0.1. So this log of 0.46, 0.5 is minus 0.301. So in this tabular column they have given. So now you substitute in this value in the here. So pH is equal to 4.76 minus 0.301 is equal to 4.459. So approximately 4.36. So answer is option A. Same questions. So an acetic buffer is represented by mixing of 2 ml acetic acid, 1 pint sodium acetate, pK of acetic value, and calculate the pH. Same questions repeating over here. So you clearly understand. So they have given us acetate salt value and acid value and pKa value. So now you are substituting, you will get this finally, and you will take the log of this log 5, you will get the value, and you substitute the pH of 4 pKa value minus log value, you will get the answer. So option A is the answer. So next, the buffers and conjugate pairs. So buffer weak acids and conjugate base salts, acetic acid and sodium acetate. It's a buffer system. Formic acids, sodium formate. It's a buffer system. So next, the buffer system, how it's work. It is very important, the mechanism of buffer, how it is working. So first we will discuss about the acetic buffer. So acetic buffer is it's a composition of acetic buffer. So acetic buffer means in a beaker you used to take acetic acids and sodium acetate, these two compounds. So acetic acid will donate the hydrogen ion and acetate ion. At the same time, sodium acetate donate the Na plus and acetate ion. So this is called acetic buffer. So what is mean buffer? When we are adding the excess of acids or base, so it resists the change in the pH. So buffer system means it should not produce any changes in the pH. So once we have prepared this buffer by combination of acetic acid and sodium acetate, so any acids or base when we are adding, it should not uh, produce any changes in this solution. So suppose this acetic acid buffer is 3, pH is 3. In the pH 3, we prepared this buffer system. So this buffer system, it should maintain its pH over the period when we are adding the acids or any base. So when we are adding acids, it pH will go into the acidic. When we are adding the base, it pH goes into the alkaline. So buffer system means it should not produce that changes. It is called buffer. So that mechanism, how it is produced, resisting the changes in pH, that we are going to explain over here. For example, this is a buffer system, acetic acid and sodium acetate. Acetic buffer, when we are adding small amount of acid into the buffer, so the acid means the pH will go into the acidic, but buffer will not allow. How it is not allowing means this hydrogen ions combine with the acetate ion of this buffer system and it's converting into the acetic acid. So again forming the acetic acid, thereby preventing the changes in the pH. So due to added hydrogen ions are consumed by the conjugate base of acetate ions and weak acid is formed. So pH does not decreases significantly. At the same time, when we are adding base of OH minus ion, so already acetic acid it's produce the hydrogen ion. So hydrogen ion is there. So that hydrogen ion combines with the OH minus ion and it's form water. So OH minus ions are neutralized by weak acid. Water is formed. So pH does not increases significantly. So that when we are adding hydrogen ion, pH is not decreasing. That means it's not going to acidic. And when we are adding the OH minus ion, pH does not increases significantly. That means it's not going to the alkaline. So that is called buffer system. Its mechanism. It's how it's work. So an acidic buffer works by neutralizing added acids with its conjugate base and added base with its weak acids, thereby resisting change in pH. In an acetic acid sodium acetate buffer, the conjugate base is option C acetate ion. If the concentration of weak acid and its conjugate base are equal, then so option D pH is equal to 7. Which reaction explains the buffer action of an acidic buffer when a strong acid is added? So option C answer. An acidic buffer solution containing acetic acid and sodium acetate. What happens when a small amount of strong acids is added to this buffer? So option B, added pH ions react with the acetate ion to form acetic acid. A small amount of strong base is added to an acetic buffer. Acetic acid plus sodium acetate, the pH remains nearly constant because option B, OH minus ions are neutralized by acetic acid forming water. In an acetic buffer system prepared with acetic acids and sodium acetate, which of the following statement is true? So option B, added OH minus ions are neutralized by acetic acid. So next is the buffer and its conjugate pair. So ammonia, ammonium chloride. Basic buffer we are going to discuss. Ammonium hydroxide, ammonium chloride is the buffer, basic buffer and conjugate pair. So now we will discuss about how it is working. Basic buffer, same like that acidic buffer only. So in this basic buffers containing ammonium hydroxide and ammonium chloride of conjugate base. So ammonium hydroxide form H plus OH minus ion and ammonium chloride form NH4 plus and Cl minus ion. Ammonium hydroxide also NH4 plus OH minus ion. So here is the alkaline buffer above 7. The pH maintains above 7. This is the buffer system. So in this buffer system, we are going to add hydrogen ions and OH minus ion. That means acids and base. When we are adding acids and base, it should not produce changes in the pH. So pH 7 is a constant, means it should be constant. Should not produce any changes. So how it is working? That mechanisms are working mechanism. Now I am going to explain. Now I am adding the hydrogen ion, excess of acid into the buffer system. So when we are adding excess of acid, the hydrogen ions, OH minus here OH minus ions are there. So the hydrogen ion react with this OH minus ion and it's converted into water. So thereby when we are adding H plus ion is nothing but acid. So it does not produce any changes in the pH. So added H plus ion neutralized by ammonia and weak ammonium ions are formed and pH does not decreases significantly. So next, when a small amount of OH minus ion is added, so OH minus ion is added, that means base when we are adding. So already ammonium ions are there. So that ammonium ions combine with this OH minus ion, it's form ammonium hydroxide. So the excess of ammonium hydroxides are neutralized by ammonium ion. Water is not formed, neutralized by ammonium ion and it's formed ammonium hydroxide NH4 OH ions. The pH does not decreases significantly. In an ammonia buffer, the conjugate acid is so option C NH4 plus. And basic buffer resists change in pH mainly because so option B conjugate acid neutralizes added H plus ions. What happens when a small amount of strong acid is added to an ammonium chloride buffer? So option C, H plus ions combines with ammonia to form ammonium ion. Which reaction is responsible for buffer action when small amounts of base is added to a basic buffer? So option D, ammonium. It leads ammonium H plus ion. A basic buffer is prepared using. So answer in the comment box. So thank you. So join in our WhatsApp community. Thank you. Like, subscribe and share.